It is Friday, finally. It is February 19th, the last day before the weekend. It's time to check our bell work. And I've got a whole mix of operations here for you because I do want you to be able to solve all operations with fractions. So the first row here, subtraction and addition. And remember with those, you need common denominators for sure. So with this first one, I'm gonna ask myself, how do I get a common denominator? What's the easiest way? I would say doing 4 times 2 would give me the easiest way because 4 times 2 is 8. So I'm gonna multiply both of those by 2 and I end up having 2 and 3 times 2 is 6/8 minus 1 and 5/8. Now if you wanted to set that up vertically, you can, but I notice already I can do 6 minus 5. So it's okay to leave it like this. So 2 minus the 1 is 1, 6 minus 5 is 1. My denominator doesn't change, so 1 and 1/8 is what you should have for this one. And looking at number 2, I need a common denominator, that's addition. And the easiest way to get a common denominator, I would say, is to do 3 times 3. So multiply both of those by 3, and I would get 4 and 6/9 plus 1 and 5/9. Okay, so 4 plus 1, that's 5. 6 plus 5 is 11. Don't do 9 plus 9. This tells me the size of the pieces. That doesn't change. We do need to change this in proper fraction, however. So 11/9 is actually 1, right? 9 times 1 is 9, plus 2 is 11/9. So instead of 11/9, I'm going to use 1 and 2/9. So 5 plus 1 and 2/9 gives me 6 and 2/9. So 6 and 2/9 should be your final answer for number 2. Okay, for number 3, there's a couple different strategies you could use for this one. I mean, the mental math strategy for me would be 1/6 plus 5/6 would give me 3, and 3 plus 4 is 7. So I would have 4 and 5/6. Okay, so this is solvable in your head. If you're like, I don't know about that, then you would set this one up vertically, because notice that you don't have a fraction to take 1/6 away from. So remember, I can't just drop down this 1/6. I need a number here, and right now it's 0. So you have to borrow. And hopefully you'll see, oh, that's what all these number talks are about, because this one is way nicer to do in your head, but it's totally fine to do it this way too. So I'm gonna borrow 1 whole from this 7, and that's gonna become a 6. Fraction-wise, 1 whole when we're dealing with sixths would be 6/6. Now we can solve it out. 6/6 minus 1/6. So if you have 6 out of 6 and you take 1 out of 6 away, that would mean you have 5 out of 6. And 6 minus 2 is 4. So that's what we had said before, if you did it in your head, 4 and 5/6. Okay, now we're moving on to multiplication. And I don't see any mixed numbers here. I do see that I can cross simplify the 6 and the 9. And if you didn't see it, it's okay. You can just simplify at the end instead. But 3 goes into 6 twice, and 3 goes into 9 3 times. So 4 times 2 is 8, and 3 times 7 is 21, and now we're set. For number 5, 1 and 1/3 times 1 and 3/8, you do need to change these into mixed numbers first. So 3 times 1 is 3, plus 1 is 4/3, and 8 times 1 is 8, 9, 10, 11, 8ths. So for this one, I would definitely cross simplify the 4 and the 8. If you didn't see it, you'd get 44 over 24, and then you'd be well on your way simplifying that, right? But we can say 4 goes into 4 once, and 4 goes into 8 twice. So we get 1 times 11 is 11, and 3 times 2 is 6. It's improper. 6 goes into 11 one time, and 6 times 1 is 6, and I know that 6 plus 5 is 11. So you'd get 1 and 5/6. And if you did multiply and you had 44 over 24, you would still end up getting 1 and 5/6 when you simplify it at the end. Okay, number 6. I need to change this mixed number into improper. So 10 times 2 is 20, plus 9 is 29/10 times 15, and I'm going to put a 1 underneath that. You do not have to do 29 times 15. You can if you want, but I would rather divide the 10 and the 15 both by 5. So 5 goes into 10 twice, and 5 goes into 15 3 times. So now I'm left with 29 times 3. And again, a couple different ways you can do that. You can say, okay, well, 30 times 3, 20, 40, 60. and then that's 1 less each time, so 59, 58, 57. You can say, well, 3 times 20 is 60, and then 3 times 9, that's 27, and add those two together, okay? So, I meant to say 30, 60, 90. Sorry, I'm catching all my little mistakes. It's actually quite early on Sunday morning for me recording this, and I have my coffee right in front of me. So, anyhow, I'm just gonna set it up traditionally because I feel like it's good practice for a unit to come. So 29 times 3, I can set it up like this. Maybe this is like, oh yeah, I remember that. And 9 times 3 is 27. And 3 times 2 is 6 plus 2 is 8. So that's what I was talking about. If you look at this as like 30 times 3, 30, 60, 90, and then take 1 away because 29 is 1 less than 30 3 times, you'd get 87. Anyhow, 87 over 2 times 1 is 2 is what you should have. So now you have to do 87 divided by 2, right? And I know that you don't, you haven't really learned the standard algorithm for this. It's not actually until 6th grade that you're supposed to learn that. So we're gonna have to figure out some strategies of, well, how can I figure this out, what 87 divided by 2 is? And you can use some facts that you already know. So that's what I'm gonna do. Let me get a different color here. If I wanted to do 87 divided by 2, I know that like 40 plus 40 is 80, right? So I know that 2 times 40 is 80 because 2 times 4 is 8 with a 0. And I just need 7 more, right? So I've used 40 so far. 2, 4, 6. Well, 2 times 3 equals 6, and that's 86. That's as close as I can get, right? So 2 would go into 87, 40 plus 3 times 43, and then I'm at 86, right? I need to get to 87, so it would be 1 more out of 2. So 43 and a half. Whew, that one was exhausting, wasn't it? I know. Okay, we looked at this yesterday, and we had talked before about how 8 divided by 9 is the same as 8 times 1/9, right? And that gives me 8/9. And we just learned in class that if you have 8 divided by 1/3, then that actually means the same thing as 8 times 3. That's the multiplication problem you can use. So 8 divided by 1/3, we learned yesterday, would give us 24. 7 divided by 1/10, we learned is the same as 7 times 10. So 7 times 10 would be 70. And if you're picturing this, we have 7, and we're chopping up each one of those wholes into tenths, okay? So if you have 7 and it's cut up into 10, so 1 7 is 10, another 7 is 10, another 7 is 10. So that means you have 10 7 times. Yes, which is 70. All right, last one, 12 divided by 1/4. That means you're taking 12 and cutting them up into fourths. So what would you have? You would actually have 12 times 4, which is equal to 48. All right, we're finally done. Thank you so much for checking your work and working so hard. I appreciate it.